4 and then the square root of 2
is what? Oh, sorry, square root of 4 is 2. Says the answer.
Okay. These values you'll need to memorize.
Because like I said, we're going to use this table for every single one. It's not hard to memorize. Just remember, you always start with 0 and then go 1, 2, 4, and then take the square root of these numbers. Alright, and that's what this graph is. That's these points right here. And we're also going to list the domain and range for every single graph. So domain's dealing with what values? What's the smallest x value we have? Good. And it goes to what? Yes, it goes right forever. What's the smallest y value we have? Good. And does it, what's the highest it goes? Yes, because as it goes this way forever, it's also going what? Up forever. So that's the domain and range of your parent graph. Will it always be that? No, it's going to change. And what makes it change are transformations, which we've talked about, I know, like 4 times. So this should be a review. Transformations. If there's a number, let's pretend this is like a number 2. On the outside, away from x, is it moving your graph which direction? This number. Let me write it like this. If I had 2 square root of x plus 2 plus 4. This 4 is moving our graph what? Up 4. Good. So the k, if it's on the outside, not with the x, it moves it either up or down. What determines whether it moves up or down? Good. So if it's positive, it moves it where? And if it's negative? Alright, now if I had a 2 right here, that's moving my graph which way? Left to right. Good. If it's with the x inside the square root, it's moving it left to right. What determines that? Yes, so if it's negative, like this one is it moving it left or right? Good, because x is a what? Yes. If it's positive, it's moving to the left. So opposite of what you might think. And what is this 2 doing to my graph? That would be if it was a negative. Yeah. Yeah, like stretching or shrinking, right? But if it's on the outside, away from the x, it's changing which value? Yes, y. If it were on the inside, like a 3 right here, it would be changing your x value. Okay, so that's important to know. This is changing our y values. Alright, now we're ready to graph. Flip it over. Starting with, I'll do 2 of these with you. Any specific ones you want to do together from this page? 3. Any other ones? Alright, I'll just do this number 2, the first one. So we'll start there. Alright, first thing you're going to do when you graph them is make your table using the original parent graph x values and y values. So what were the x values? Try not to look back and cheat. And then the y values? Good. You're always going to start with those for every graph. Alright, then you look at this function and seeing what's different about this compared to this parent graph. So what's the difference here? The 3 and the 2. What's the 3 doing? Good, so it's affecting x or y value. Good. What's the 2 affecting? Yes. Alright, and again, somebody said it, but what's the 3 moving it left or right? So what we're going to do is subtract 3, the opposite, to all our x values. We're going to subtract 3 from every x value. And what do you think we're going to do to the y values? Plus 2. Good. Because x is a joker, so if it's moving to the left, it's moving backwards. So that's why we're subtracting 3. Does that make sense? Like this 3 is moving it to the left. So that's why we're subtracting x is a joker. So if I subtract 3 from 0, I'll get what? Very good. If I subtract 3 from 1, next one. Next one. Good. And if I add 2 to all of these on this side, what's my y value going to be? And good. So what you're going to do is graph these new points. You're going to graph negative 3, 2, which is going to be right here. You're going to have negative 2, 3, which is going to be right here. Negative 1, 3.4, and 1, 4. What is the center or the starting point of this graph? Good, the first one we started with, negative 3, 2. So you're always going to start there and then connect the other points. And square root functions will always look like this. Any questions about that? The last thing we have to do is our domain and range. So domain for this one, tell me the smallest x value. What's the furthest left it goes? And then goes to how far right? Good. Everybody see that? Smallest x value, negative 3, goes to infinity. The range, what's the smallest y value? Good. And goes to? Perfect. Questions about that one? Cool. Alright, moving to number 3. And by the way, on these you don't have to describe it. Like we used to with transformations, you don't have to describe this. This is all I need for your test. Alright. Number 3. Tell me the original x values. Original y values. 1, what's this one? Good. Alright, now we're going to look at the function, see what's changing. Tell me one transformation you see and what it's doing. Good, so this is affecting our y values. What's another one? Right, 1, so it's affecting x values. And then we see this negative 1/2. Is it beside the x, like with the x, or away from it? So it's affecting which value? Yes. So the first thing we're going to do is look at just the x value. What are we going to do to these values right here? Add 1. Good. You do the opposite of what it is. So this value is going to be good. Alright, the y is a little different. We're going to start by going left to right, looking at what's happening. We're going to multiply by this negative 1/2, so times 1/2, excuse me, negative 1/2. And then we're going to do what? Subtract 2. So multiply these by negative 1/2 first, then subtract 2. So let's do 0, 0 times negative 1/2, minus 2. Good. 1 times negative 1/2, minus 2. Good. 1.4 times negative 1/2, minus 2. Go ahead and find that value. What'd you get? Try that one again. What'd y'all get on that one? Come on. Yes, that's what I was looking for. Make sure that when you're doing this, you're multiplying it by negative 1/2 instead of dividing. What's 2 times negative 1/2? Minus 2? Negative 3. Good. Questions about those values? Go ahead and graph them. What is my starting point? What's my starting point? 1 what? Negative 2, so I'll start there and draw my graph. Alright, so we know that the 1 moved it over to the right one. We know the 2 moved it down 2. What did the negative 1/2 do? Reflected it Plus it made the numbers right here close together, like the dots more closer than these were. Everybody notice that? Alright, now for domain and range. Tell me the domain. One, two. Good. What about the range? -2 to what? Yes, because it's going down forever. So which one has to come first? Good. Negative infinity to 2. -2, excuse me. Questions so far? I want you to do 1 and 2 on your own. Make sure to list the domain and range because that's very, very important when you get to pre-cal. Go ahead and see what some of the people around these graphs look like. Compare and see the domain and range too. Go ahead and do that. Alright, we'll start going over them. I'm going to call on people for first the original X and Y values, okay? So going down the line, Caleb, start with the first original X value. Alright, next. Amy. Good, next. Good, next. Next. Good, Sid. Next. Good. Alright, now the changed X values that you have. So starting Nicole, I think I left off. Yeah, go ahead. Good. Next. Next. Good. Next. Alright, now the Y values. So Nikki. Good. Abigail. Good. Rihanna. And Brandon. Alright, so the only thing that changed is our X values. I'm going to go ahead and graph that part. And I don't have enough room to graph all of it, so there we go. Alright, Toby, tell me what you got for domain.
Bracket.
Good. Alright, Sawyer, for the range.
0.
Perfect. Any questions? Everybody good? Alright, moving on to the next one. So, starting with Julia, original X values.
Here.
Good. Catherine?
1.
Madison?
2.
Connor?
4.
Simon?
On the Y values?
Yep.
0.
Bryant? Back to you, Caleb.
4.
Next.
2.
Good. Now the changed X values. Amy?
5.
Next.
6.
Next.
7.
Next.
9.
Good. Now the Y values. Who left off? Go ahead. So what'd you get for your Y value?
Oh, -4.
Next.
Oh wait, the first one's -6.
Okay. Go ahead. Go ahead. And last one. Everybody good with these values? Alright, I'm going to graph them. 6, 6, -4. Alright, this one looks a little different than the ones we've been doing. How does this one look different than the ones we've been doing? Yeah, it's steeper. And what makes it steeper? The 2. Very good. Alright, who did I leave off with? Who said the last one? Okay. William, tell me what you got for your domain on this one. And Taryn, your range? Y'all agree? Very good. Alright, what I want you to do is look at your domain and range for each one, and then look at the original function. Take time to look at all of them, and then I want to talk about a pattern that you see. So look at domain and range and your original function for all 4. Would you be able to tell the domain and range without the graph? Yes? No? Yes? Okay. So without the graph, how could I tell what the domain and range is from this graph?
The 3 and the 2.
Yes, but this one's different, right? -3 and 2. Same thing here. Even if there's a number in front, again, the X, the domain is with the 5, and then the range is with -6. Everybody see that? But this range is a little different, and why is that? Why does negative infinity come first? Good, because the negative changes it. Everybody see that? Okay, so flip over. What we're going to do for numbers 1 through 7 is just find the domain and range without graphing, okay? So let's just do number 1 together. Can you tell me the domain? 0 infinity. Good. If you cannot, if you have trouble with it, just take what's on the inside the radical, 4x, or whatever it is, set it equal to 0 and solve. Okay? So the domain would be 0 to infinity. What about the range? What'd you say? Yes, because there's no y value over here. Everybody see that? So y comes from here. X, just set the inside of the radical equal to 0. Go ahead and do domain and range for 1 through 7. Excuse me, 2 through 7.